What secrets are revealed when we unfold nature? A bird on a tree spreads its wings wide and leaps into the sky. In that moment, the wind feels as if it is caught. When the wings are folded and when they are open, air responds in a completely different way. Birds do not spread their wings only to fly. They spread them to look bigger when facing an enemy and to win a mate's heart. The Victoria's riflebird of Australia dances by shaping its wings into an oval frame. It is their clearest, most beautiful way to say, "I am here." Flying squirrels are similar. When the membrane between their front and hind legs spreads wide, air flows underneath and creates lift. They move from tree to tree not by jumping, but by gliding. This principle also applies to sailboats and parachutes. In the past, boats could move only by rowing or riding the current, but once a sail was raised, the wind became power. It is the same wind, but an open sail catches it and turns it into a pushing force. A parachute works the same way. When it spreads wide and increases air resistance, the falling speed slows and it can land safely. Picture a male peacock or pheasant spreading its tail feathers like a fan. As they open, patterns appear. A complex pattern, many colors woven together, revealed all at once. The reason is clear: to win the female's attention. It is a kind of proof of health and genetic strength. And when competing with another male, those tail feathers become a large shield. Especially when a peacock spreads its tail like a fan, countless fake eyes appear and make the opponent flinch. It is an illusion to make one animal look as if it is surrounded by many. The frilled lizard is just as unforgettable. It stays calm most of the time, but the moment it senses danger, it opens the frill around its neck like an umbrella and gapes its mouth wide. It is a strategy to make themselves look suddenly bigger. Sometimes, this spreading is used for courtship or temperature control. Spreading and folding are not just fighting, it is closer to a whole way of living. Plants spread and fold too. Maple seeds come in pairs, like little boomerangs. As they fall, they spin and spin. They look just like tiny helicopters. When a seed starts to spin, it stays in the air longer and meets more wind. It is a way to spread farther. Even more surprising is this. After it falls to the ground, a gentle breeze can make it lift off again. The seed waits for the right wind and earns one more chance. Mimosa plants fold their leaves at the slightest touch. When stimulated, water shifts inside their cells and the leaves close. It is a survival strategy to startle animals that try to eat them. Some plants spread their leaves wide during the day, then fold them at night. It is to reduce water loss. Opening and folding are changes in form and a quiet calculation of gain and loss. Here, mathematics begins to show. To open is, in most cases, to increase area. More precisely, it often means increasing the projected area that meets wind or light. Then, the force of the air, the resistance the air creates, and the amount of information the eyes take in all increase together. In short, it is simple. Open it and the area increases. As the area increases, wind and light, and what the eyes can catch, increase as well. So flying becomes easier, falling becomes slower, the body looks larger, and the seeds can spread farther. In the end, it survives better. This principle can be seen even in a single sheet of paper. Each time the paper is folded in half, its size shrinks and its thickness grows. Unfold it, and the area expands. The creases, symmetry, and shifting angles created by folding and unfolding are no longer just a hobby. They have become a design language of advanced engineering. The genius Japanese astrophysicist Miura studied origami patterns to reduce the volume of space equipment. He designed solar panels that unfold wide with only a small force. Folded small, then expanding at once when needed, this idea is used not only for giant solar panels in space, but also for car airbags that must deploy in 0.01 seconds, and devices like temporary shelters at disaster sites. Now, this structure has become a core language of advanced engineering. In the end, nature seems to say, unfold it, then unseen forces will appear.